Good morning and welcome to Innovation in the Aerospace and Defense Industrial Base. If you have questions for the speakers during this session, please enter them into the chat feature. And now we are pleased to welcome our moderator, Mark Hanlon, Lead Director of Denver Production Operations for Lockheed Martin Space. Take it away, Mark.
Good morning, everyone. I was asked to host this panel and share some of the issues that we have here with production. I think what we're going to hear is many of the things that I bring up are common to many areas. Here in Lockheed Martin, it's all about getting product, whether it be a black box or a structure, to spacecraft integration. If the hardware is late, we impact potentially the launch date, which impacts both Lockheed Martin as well as the customers. Things that I think are systemic that affect supply chain, giving product to production is producibility. Do we have a design that a supplier can build? I have an example that I just went through where a supplier struggled for 1 year to provide a PWB for a black box. We lose time in placing POs. There's disagreements between supply chain as well as the suppliers, which delays the placement of the PO. Quality obviously is extremely important. When we find a defect from a supplier midstream, it forces you into workarounds and impacts both cost and schedule. And then the volume at the suppliers. We do run into cases where we have a commitment from a supplier and base all of our schedules on that commitment. And unfortunately, within a month or weeks, the supplier informs us that they no longer can support that commitment because they're over capacity. So the panelists that we have here today are Jeff McElvey, and he's the co-founder and chief process officer from Tempo Automation, as well as Chris Powers, the CEO of ASCEND Ventures. As well as Suman, who is the CEO of DDM Systems. And at this point, I believe we can have some opening remarks from the panel.
Hi, folks. My name is Jeff McElvey. I'm co-founder and chief process officer at Tempo Automation. We are an electronics manufacturer based in San Francisco. Our perspective is that the experience of developing electronics should be akin to that of developing software, and specifically the speed and the seamlessness as the key dimensions there. The same way you can compile your code at the press of a button, we're trying to realize the vision where you can compile your electronics in as close as to that as is physically possible. So the how behind the hood for us is we have brought a high degree of software to automate both the design for manufacturing experience, but also the manufacturing floor that runs our factory. And so we think about an unbroken digital thread that helps us go from the engineer's design directly to the factory floor with minimal manual touches, but also the close of the loop. And as we have learnings about what works well and what doesn't work well on the factory floor, we feed those back to our customers so that they can be the most successful in the next revision of their design. The upshot of all this is that we're able to go from design to board on desk, including finding parts, finding boards, assembling and delivering in a matter of days, when many of our competitors will take weeks and months.
Cool. And I'm Chris, CEO of ASCEND Ventures, and we are kind of like Jeff, except in the machining space for high tolerance precision components for space and defense. And effectively, a lot of the problems that I saw when I started looking at this were exactly what Mark just ran through. It's completely insane that a lot of the space and defense programs have got a 50% production buffer in because we can't simply get a component on time, even after you've given someone a purchase order and they've committed it. And, we track back that problem to these thousands of high precision machining operations with very little data and systemization to it, causing all these knock-on effects in the two most critical industries in the United States at the moment, space and defense. And our strategy is basically, we're acquiring those operations because they've got great programs, critical knowledge on how to make these components, and we need that for the survivability of the defense manufacturing base. But then we're backing in the latest software in terms of algorithmic scheduling, deeper machining technology, and a better customer experience for the buyer and the engineer on the OEM side, basically to solve all those problems for the OEMs. And, Jeff used a software example, and the example I've been telling people is, 10 years ago, you got 50% of your software engineers at any startup, the most expensive people on the planet, running around making sure the servers didn't die. And then AWS comes along and it's a click of the button. So your headcount goes down, everything just works. And all the brain power is focused on building better software and solving problems for customers. And that's what we're going to do here is remove all that useless work, automate everything to the point where maybe we're not reducing lead times, but at least we're hitting that mark every single time of when we promise the customer and providing a way better customer experience. So yeah, that's what we're doing.
Good morning, everyone. I'm Suman Das. I'm the founder and CEO of DDM Systems. DDM Systems is a digital foundry. We are disrupting and modernizing the way the most precise metal castings are made anywhere across diverse industries, including space. The company was founded on work that was supported by the Defense Advanced Research Projects Agency to disrupt and modernize the casting of the most advanced metal parts you find anywhere, which are the high pressure turbine airfoils on aircraft engines. From there, we've done several years of work, and most recently, we have entered into a partnership with Signicast, which is the leading steel and aluminum investment casting foundry in the United States. And we are joining hands to offer the technology to various customers to be able to dramatically shorten the lead time for prototypes, to dramatically increase the ability to make multiple prototypes very quickly, and eventually take the same approach, the same baseline technology to production. So there's going to be no difference between the method you utilize to make prototypes versus the methods you eventually use to ramp up into production, whether it's low, medium, or high volume, depending on the industry sector. The way we do this is that we deliver cast quality parts, but that are made with the convenience and the flexibility of advanced 3D printing. So as opposed to most other metal 3D printing technology that you see, and I was one of the first in the world actually to produce metal 3D printed parts under a Lockheed Martin program with DARPA to make nose cones for the AIM-9 Sidewinder missile, as opposed to printing metal parts, which can be very slow and very difficult to qualify with lots of expense involved because the metallurgy is totally different. What we are doing here is we are guaranteeing the cast quality metallurgy that you expect from an industrially established process of investment casting, but we are dramatically shortening the path to getting that casting by producing the ceramic shells that are required to cast those metal parts by printing them instead of going through 6 steps. So we take out 6 out of 12 steps, dramatically speeding up the process. I'll give you one example. If you have a new part that's going to go on to an aviation vehicle or a space vehicle, it may take you 2 years to get to a first article that can be fully qualified. We can dramatically shorten that lead time to about 8 weeks because we don't require any hard tooling. We don't require a lot of the intermediate steps and a lot of the manual handling and all the associated re-engineering that goes. So just a few more comments really quickly. This is a very interesting panel, and I'll just say a few things in that context. So in order to be able to fully exploit this type of capability, there's a need for various software engineering tools, complete complete integrated and connected process chain that can go from what we would call CAD to casting with all the other intermediate multi-physics modeling that is required to fully optimize. We're in the process of building all those tools so that we can offer any OEM anywhere on the globe to be able to deliver the CAD file of the desired casting to our secure portal. And we would do all the engineering required to computationally optimize the shell and the internal passages required, the core structures, to deliver a casting with 95+% probability that in the first iteration or the first 2 or 3 iterations, you would actually get a commercially acceptable part. The last thing I would say is that this type of capability breaks that dependence of the manufacturing constraints that we've had on tooling that allow only certain geometries to be made. It opens up an entire range of new geometries, including lightweighting and topology optimization and generative design that can be very important for space launch when you want to cut back on the weight. You could get as much as a 50 to 70% weight reduction, but yet get the same mechanical performance. But now you need a method to make it. Now we have the method to make it. So I'll stop there and happy to add more thoughts and comments and answer any questions.
Thank you very much. What I've done is I have 3 questions that I'd like to hear from each panelist, and they're a little more generic. And then I have some specific questions that I'd like an individual panelist to answer. So the first question that I'd like to hear from each of you is, what do you see as the biggest emerging threat to aerospace supply chain performance? And we can start with Chris.
So I'm going to cheat and say 2 things. And since we're in the national security community watching this, I can say the quiet bit out loud. It's China is the first one. I'm sure everyone knows the examples that I'm not sure if we can talk about of what the Chinese have been doing in the space supply chain, from restricting key components from being used in space startups to other things. Tori Bruno from ULA came out yesterday or the day before and said they found a critical component in their KUKA robotics stack where it was sucking data out to China. And unfortunately, the most vulnerable bit is the subcomponents layer, where it's mostly small businesses that do not have the cyber capability that ULA has. So that is the biggest one. And the second one is, you've basically got the entire industry in non-consolidated kind of fragile small businesses where the owner operator is somewhere between 60 and 70. That's not a bad thing, but it's going to be a bad thing in about 5 to 10 years when, frankly, the sons and daughters don't want to run these companies and take it over as a family business. So either they're going to get sucked up into the hands of, really predatory private equity firms who aren't there to, help space and defense just to sit there and raise prices, or we're going to have this cascading effect where, they're all going to go out of business at the same time, and no OEM has the capability to respec all those components, when that wave hits. So I'm not sure which one is going to be the most scary over the next 5 to 10 years, but yeah, it's China and, kind of that fragmented aging owner base. That's the scariest bit.
Thank you. Jeff, your thoughts?
Yeah, and so I agree with both of those, and I'm going to elaborate on the second one. I think we see the same thing in the electronics assembly market. So there's maybe 1,300 kind of mom and poppy type of outfits doing electronics manufacturing around the U.S. And the demographics are similar. I think there were decades where manufacturing was not a career that was really aspired for domestically. And right now we have an electronics manufacturing skill base that reflects that. And so as these folks retire out, there aren't folks to backfill them. And so that's a little bit behind our view that by encoding a lot of the sort of knowledge and know-how that folks have in software, we're able to preserve that learning, that experience, that insight, such that the parts that we produce and the designs that OEMs make are able to go in and code that knowledge going forward.
Thank you. Suman?
Thanks, Mark. I'm going to take a slightly different tack. I think that the biggest emerging threat to the aerospace supply chain today is the COVID-19 crisis. and you can see the bloodletting that's occurred across the entire aerospace sector. And there are projections. Not a single week goes by that you are not seeing a news release that comes out about a major OEM, a major prime contractor that's announcing massive layoffs, massive cutbacks. That is having a cascading effect on the entire aerospace supply chain. You can see that happen. There are established companies that have been around for couple decades, 3 decades, that are actually shutting down. They're just shutting down. And so this is going to have a very, very strong and cascading effect across the entire supply chain. It's going to take years to recover. There may be some capabilities that are going to be lost and never will come back. It's going to require a massive reconfiguration. It's going to require massive support, especially for this national security sensitive technologies. The government is going to have to step in. You can already see that for the likes of GE. They're getting major contracts, DoD contracts. The casting foundries, they're being kept busy with military contracts because the aerospace, there were 12 new aircraft engines that were going to come out next year. That's not going to happen anymore. And the foundries were backed up to 2024. That's not happening anymore. There are the biggest of the big guys are basically letting people go. So I think this is going to take years to recover. And I think in light of some of the comments made earlier, it's going to be really interesting what happens in other parts of the world and how they reconfigure and recover out of the COVID-19 crisis. The other big unknown is we don't know how long this is going to go on. There are some predictions that this is going to go on till end 2021. If you look at especially the physically intensive industries where people are required to be in factories making product, and you're looking at reduced headcount, and you have to carry out all the safety requirements and protocols, it's going to be tough to put out product at the rate at which it was coming before the crisis hit. So I think there's going to be some pretty significant threats there. How are we going to come out of it? What the government is going to do to especially support the security sensitive industries?
Thank you. The next question is, what are the biggest differences between aerospace and commercial supply chain practices? And why don't we start with you, Jeff?
Certainly. Yeah, I think that what we see is the cost of being wrong and the importance of keeping to schedule, I think, are really differentiated in our aerospace customers contra some other ones. I mean, I think that when you think of folks doing some of the consumer products, if something breaks, it's disappointing. Maybe you have to do with a recall or return, but it's not going to be typically that people are going to die or millions, if not tens or hundreds, burst into flames. And so I think also given the launches are such, and the timing they're around are such binary events, it becomes really important that things stay on schedule. You don't have one critical path component just blow up the whole timing and you miss your launch window. And so really the quality, on-time delivery, and speed are the 3 things that set our aerospace defense customers apart from the other folks in our customer base.
Thank you. Suman?
Yeah, so I think this is something that we've encountered, and we've had to configure our own approach and entry into the market. And that, I think, the key difference in my view is the qualification process and the qualification lead time. Everybody knows that if you are a new player on the market offering some new technology, that the path to qualification is going to be especially long, especially when you're dealing with certain mission critical parts or mechanically loaded parts and things like that. So that certainly presents a barrier to a new disruptive technology. In our case, general rule of thumb is that if you're a new supplier of metal parts or you're a new foundry, it's going to take you probably 3 years to get qualified, right? So that presents significant barriers. On the other side, it's much easier to get into the commercial supply chain, establish a presence there, and work your way up the qualification ladder. So I think that to me is the big difference. In the military world, yes. In the defense world, it's not too easy for a small player with a fairly valuable technology to be able to come in because of the contracting, all of the issues associated with contracting. Even if you're coming in to supply spare parts for legacy vehicles, there is a difficulty, there are barriers, and a lot of people say, well, you're better off by going with someone, a big player that already has an ongoing established presence and established contract. So I think from a small business, small company, startup point of view, I think qualification and the fact that you don't have deep pockets to spend the money to do all the qualification to get rapidly qualified, those are some of the hurdles. So it's always useful perhaps to partner up with a big player and then get your entry that way.
Thank you. Chris, your thoughts?
So I actually think there's three kind of cuts to this. One is, general or commercial aviation, and then there's kind of space and defense. And I actually think the biggest difference is how fast I think commercial aviation behaves like automotive. It's like you're working for Ford or GM when you work for Boeing commercial. It behaves like that. It's more rigorous. Things are squeezed, trying to kind of top to bottom. I think space is more dynamic and iterative. People are moving so fast with rev changes and design changes that the pace of the OODA loop in the supply chain is, months or, a quarter or something like that. Whereas the pace in commercial is years. Suman was talking about the new Pratt & Whitney engines that were going to go on the, Airbus and Boeing planes. Those have been all delayed, but that's a 4 to 5 to 10 year kind of product cycle. Whereas we see space startups or even the big established players like Planet and SpaceX still doing rev changes all the time. So I just think that the biggest difference is the pace and the dynamism and how fast things are moving in terms of, that iteration cycle and where things are chopping and changing. That's the biggest difference I see.
Excellent. All right, the third and final question for all of you is, how is your business uniquely tackling these major challenges? What are some of the latest advancements you see? And we can start with Suman.
Yeah, so I think I'll speak to both the software and the hardware side of things. I think that there have been tremendous advances in design and simulation software and the integration of that didn't used to be about 10, 15, 20 years ago. A lot of the major design vendors, the CAD vendors, are integrating all the simulation capabilities so that they're moving more and more towards, they're not quite there yet in terms of having an end-to-end design through simulation capability up to a production-ready design. So I think that is dramatically speeding up the pace of innovation, along with some of the newer software that is breaking the established paradigm for design. So there's some new companies that are coming up, especially very well suited for the additive manufacturing space, where entirely new types of software are coming in, which are giving dramatic capability that allows designers to rapidly design very complex designs that would previously take months. I mean, there's actual examples where what would take 2 months to produce a design, a mechanical design that with lots of periodic architecture inside, can now be done in 5 minutes. So that is dramatically increasing the pace of innovation. And along with that, there's the evolution of new additive manufacturing technologies that basically allow us to be able to produce multiple prototypes quickly. So do a massively parallel screening of multiple prototype design variants and to be able to down select the one that is eventually going to get selected for production. So there's the ability with printing machines, whatever other 3D printing technology might be, with larger and larger platforms. But there's still quite a ways to go before we actually can get into printing speeds that are going to be suitable for production. But that's going to happen because people are realizing you cut out so many steps in the design, in the actual manufacturing process, and you can go much quicker and you can change your designs very fast, and you can as results and outcomes of simulation come out telling you that a change to a design will lead to some dramatic improvement in performance. Now that can be tested very quickly, and it can be tested with a very small supply chain or many cases in-house. So these are some of the advances that are enabling. And I think the third thing I would say is that there's also been tremendous improvements in the actual enabling technologies that allow us to build improved, higher quality machines. And the cost of those enabling technologies is coming down dramatically so that those can all be integrated into making it into an affordable but yet production quality machine. I'll stop there. Thank you.
Thank you very much. Chris, your thoughts?
Yeah, so I mean, the two biggest problems, with China and kind of the supply base in machining, disappearing in 5 to 10 years. And the way we're tackling that is basically providing a pipeline for exit, both for the OEMs who want someone to take over these businesses in a stable way, in an innovative way, and not in a predatory way. And for these owners, where often, there are a very small universe of buyers. So, providing that pipeline for all these small business owners where we actually have the operational capability to ingest these businesses into our own kind of larger swarm of machines, and the know-how and the respect to deal with the OEMs and say, okay, well, we're taking over this business. How much inventory do you need for the next 9 months? Let's build that up. Then after that's done, let's switch everything off, recertify everything with our new production processes and kind of go from there. And it's actually not that hard. It just requires a bit of forethought. So I think that's the main one. And the China thing, I actually think it's a how big can you get game, both on the cybersecurity issue and cost and scale and efficiency. There's nothing new we need to invent in machining that's going to kind of 3 or 4x the efficiency, to be perfectly honest. All the puzzle pieces are there. You just got to stick them together and then be at least more efficient so the industry lets you scale. You got the biggest machining operations are doing like 20 or 30 million revenue. And if you think those guys are ever going to be more efficient than Foxconn, everyone's lost their minds. So just the ability to scale, and then coming from San Francisco and a technology background, and just, the future is unevenly distributed. None of this is particularly hard. It's just particularly unevenly distributed in machining. So yeah, that exit pipeline and just bringing this scale and efficiency view is how we're tackling those two problems.
Excellent. And then last, Jeff.
Yep. So I guess I talked about quality, speed, on-time delivery as being really central to the aging labor force to the problems to face the industry. And so I really think the software that we introduced to low volume electronics manufacturing is what helps us address both of those. I think there's 2 key respects in which that's the case. I think the first is that by introducing the software, there's less manual steps. And that those manual steps mean that it's less opportunity for operator error. But it's also less queuing time, I think, as the available workforce who has experience to execute this work shrinks. You don't run up big queues in front of the folks who need to take a look at the design before it gets ready to go, for instance. The second thing that our software unlocks is the ability to really catch problems before they happen. And so that by sort of guiding folks as part of the design for manufacturing process and leveraging the experience that we have from every other design that we built, it really gets us to a place where we're doing the first time right on a more consistent basis. That's less shots on goal to our quality inspection processes and team. And it's less delays because there are surprises because like, oh, we thought it's going to work great, but something blew up along the way, and guess what, customer, it's going to be another couple of weeks. And so I think it's really having those less manual steps and using the experience that we have to catch things before we happen are how we're really setting out to deliver differentiated speed, quality, and on-time delivery to aerospace and defense.
Well done. Okay, I have several questions now that I would ask that one of the panelists respond to, and you can fight amongst yourselves. The first question, and this sort of ties back to my lead-in, pertains to data and engineering. How can we align the use of common digital tools to enable E2E product specs, that i.e. bid to 3D designs, building to models, inspect, accept with digital documentation, and the use of AI visualization?
I'm happy to do that one, unless folks protest. So I think one of the reasons that I'm passionate about this one is we've actually been working with a variety of folks to try to bring the IPC 2581 digital standard to electronics design and manufacturing. And so there's a number of folks involved in the consortium, including Lockheed and a variety of other players. And really the principle of it is you look at electronics design and there's a host of different file formats and oftentimes there's a manual translation from whatever CAD tool folks have to what's going to run on the factory floor. And so our view is that by having a common vocabulary and having the CAD tools output a file in this common standard, it really lays the groundwork for that unbroken digital thread from the design to the manufacturing process on the floor. I think that the tooling that you can write then, we work on things like being able to sort of superimpose historical defects on visualizations of the CAD design that are rendered based on sort of the pictures that we've taken of historical designs to really guide folks to see what are the hot spots on their designs to make sure they aren't going to run into the rocks in a later revision based on a lesson that could have been learned from a prior revision. So those are a couple of examples of ways in which we think that IPC 2581 digital standard is one that if folks get on board with it, it's really going to create a very different way of doing electronics design and manufacturing.
Excellent. The next question pertains to my comments relative to yield and quality. Complex designs, requirements, and process present constant challenges to our suppliers. How can we prime contractors to help improve supplier yield? How can we avoid post-delivery defects resulting in poor cost and schedule performance that impact our deliveries?
I can jump in here if everyone,
okay.
Unless you want to do this. So I think I have a weird view on this. I don't think it's a technology problem. I think it's an incentives game, in the sense that everyone knows that post-qualification, you are so locked in and you almost have a reverse monopoly on the OEMs that post that, you have literally no incentive as a business owner or a salesperson or whoever to really, really keep up with that, that service level that you sold the customer on in the first place. Because the reality is, if the incentives were there, it's not that hard to just deliver stuff on time or, do some heroics on the factory floor to make sure it happens. But because of the stuff, Suman was talking about, there's this 2 or 3 year certification process. Well, guess what? That's a barrier to entry. And unfortunately, it's too high a barrier to entry because it means less competition. And, I've been talking to people at Lockheed and even SpaceX and stuff. And the poorest performing suppliers cannot get kicked off the programs because the cost is just so incredibly huge and painful and scary. Because you know what? It's a bit of an IBM problem. If I'm the head of like Lockheed Martin F-35 supply chain and I've got an underperforming supplier who's not delivering on time, they're only delivering on time 25% of the time, or the yield is down or the quality is down. Am I going to just continue to deal with that in executive meetings, or am I going to stick my head out and recertify someone on a critical defense program? Because guess what? If that goes wrong, you don't have a job. If you kind of just deal with this underperforming supplier, you're probably still okay and you're probably still going to get that promotion. So there are wacky incentives all over the place. And, the certifications came about, in a good way. It's quality. Like, we can't be sending up people in fighter jets or rockets and there's a part that's going to blow up or something, but it's gone too far because it's creating this reverse monopoly situation. So I don't have a solution to this, but it's either people are picking favored suppliers that they're signing software SLAs with and really holding people to these accountability metrics, or they've got financial penalties baked into it. Like literally, you make zero margin on this unless you hit these SLAs, and then you're making 20 or 30%. Or we have to unlock the competitive layer to allow more of that chopping and changing. That it's an incentives problem for me. The rest of it flows from the incentives, if that makes sense.
Yes, and this, I think, next question ties into that, and we'll hear from Suman. I talked about, I believe, volume. Spent my whole career in space, and our orders are usually much smaller in quantities than your consumer technologies, automotive, etc. So we face challenges in the supplier's shop with respect to priority and economics of scale. What creative methods can be used to incentivize suppliers' performance for space products?
I think the question was maybe pointed towards me, so I'll take a shot at answering it. So I think there are two or three things in my mind which I think can really help incentivize. What is the supplier looking for? The supplier may have either an established conventional technology to make some part, or they may have something very unique that's new that could really bring dramatic benefits to the customer in terms of being able to get their parts quicker, be able to iterate through many design prototypes first, and eventually go into production, knowing fully well that the volumes or the quantities are still going to be somewhat limited. From the supplier's perspective, a supplier would want the satisfaction or the assurance that if they are able to deliver the the product, that there is likely going to be additional parts or products that they will be asked to make, because they want a long-standing relationship with a large customer like Lockheed, for example. So I think that is one important point, which is to incentivize supplier performance, get the supplier to deliver a part that both supplier and the customer agree that is a very good benchmark proof of concept or a proof of performance part, which demonstrates the supplier's capability. And if that is met, then there are going to be several other designs that would likely the supplier will get the opportunity to make. I think the other thing that could be very helpful for supplier to get incentivized and motivated is investment, corporate strategic investment made by large OEMs that show that there is a great motivation for the OEM to have the longevity of the supplier well established and not to the vagaries of the market itself. So I think those are some of the things. And then the third part is actually jointly work with the supplier. If there's a particularly unique technology, let the OEM become an anchor customer to continue to develop and to evolve that technology to get it to be better over time in terms of the capabilities that it has, but also in terms of speed, so that the low volume customer can be a good enabler, enabling that supplier eventually to get into markets where there are greater volumes demanded. And the evolution of the technology helped by the customer will enable that supplier to be able to thrive and get into larger markets.
Excellent. I'd like to remind the audience that questions on this topic are welcome. And with that, we actually do have one question from the audience, and the panelists, you decide who would like to answer it. Vertical integration has been a trend in some commercial companies. How would you recommend that OEMs balance insourcing versus outsourcing?
I'm happy to start, and folks can definitely layer on top. So I guess I think my unsatisfying answer is it depends on the dynamics for each of the different manufacturing processes and the supply base around it. So I mean, I think that the first element is like, I mean, if you already have a great supply base with a long line of folks who would be delighted to deliver excellent performance with you, then I really don't see a reason of trying to depart from what might otherwise be your core competency and sort of add one more scope to the many things that you're already already trying to bite off. I think another thing to think through is, like, do you have a really good reason why you think you could do it better than the supply base is doing it today? Do you have other technologies or abilities that could be leveraged to really do the manufacturing operation in a differentiated way? Do you have the team or a high degree of confidence that you could hire the team to be able to go and execute it excellently? I think that there's, I think not invented here is a real peril that a lot of people will run into and end up biting off a lot more than they might be able to chew. But also, like, it can also be irrational to be in a situation where there is really no good supply base to do something. And if you think you can do it better than anybody else, then you should. So that's my perhaps sort of obvious answer.
Suman or Chris, would you like to add anything to that?
Yeah, the way I would recommend OEM slice it, which is what I've talked to a lot of people about, is the high IP critical components where, you know, it's not a standardized process, you're not doing any sort of volume, you should just insource it. You just have it all in-house like Planet Labs does. You know, you're not making that many satellites or whatever. It's relatively easy manufacturing, but it's super critical to get on time and have control of that iteration cycle. You should outsource where there's some sort of relatively standardized process, even in space and defense, where every component is going to be slightly different. As long as you can abstract that away into, you know, these suppliers that do this, these suppliers that do this, and then just do a total cost of ownership calculation. You know, like the insane maths around how many machines, for example, Blue Origin would need to buy to do all their machining internally, even though the supply chain is relatively poor performance, the math doesn't make sense. And you need to look at how many headcount you're putting in to manage those supplies. You need to look at the knock-on effects. You need to look at the quality issues. It's a hard equation, but I think it is a volume. It's a volume and a speciality decision at the end of the day. I mean, obviously, I think machining should all be outsourced, but that's I'm super biased.
Suman, did you want to add anything?
No, I don't. I really don't have anything more to add at this point.
Okay.
Thanks.
Oh, no worry. All right, so the next question pertains to purchase order placement and new market entrants. How are industry partners expediting PO placement with standard T's and C's to mitigate the contractor supplier negotiation time on design, cost, quality, schedule? I know I've lost anywhere from weeks to months sometimes in finally placing a PO, which directly impacts the delivery date. How does the industry need to adjust to working with supply chain startups to capture the benefits of new innovations?
Can I take this one?
Sure.
Fire half the legal team. That would be the first thing. No, but the serious answer, I think, is what all the big companies. So I think we should copy what people did with software startups. You know, 10 years ago, you're dealing with Oracle, whatever. Now you're buying ERP from 10 guys in San Francisco, probably have no idea what they're doing, right? And the adjustment there, I think big Fortune 500 companies made is the CIO or the IT director or, you know, the vertical leader, like the HR leader or the, you know, finance leader, they're putting away 5% of their budget or 2% of their budget every year and 2 people or, you know, 20% of someone's time to test and trial one new piece of software every quarter. Because the reality is 75% of them are not going to be a good fit, but 25% of them are going to move the needle significantly. So I think on the meta layer, you just need to build that into how the business does business, because it's absolutely impossible to ask a head of supply chain to constantly be receiving these cold calls or engage with new technology because they're focused on just delivering what's in front of them right now. And it doesn't belong with like an innovation team, but I think everyone needs like an innovation chief of staff who spends all their time just filtering this and then pipelining stuff into trials in a very measured way. Otherwise, and the reason why I go back to software is because a lot of that has been standardized in terms of the actual contracting as well, both in venture capital, you know, and in software. Again, 10 years ago, to do a funding round, maybe you've got thousands of pages, and every investor is trying to do something different. And then you've got like Y Combinator coming along on the startup side, and you've got the search fund community in the private equity side, who basically standardized everything so that everyone knows what they're getting into, and there's a community involved in, oh, okay, this looks standard, let's just go and do it. And someone somewhere needs to just get all this stuff into a term sheet and then go from there and not worry about the 30-40 page contracts, along the way, which is a big ask, but that's what needs to be done.
Excellent. All right, we have another question from the audience. What are the primary drivers for the endemic lead time challenges in space systems supply chain?
Jeff, I know we're going to have the same opinion here, so do you want to just...
Go ahead and start, Chris.
It's no one is able to make a correct decision on their own capacity, and there are bogus incentives. So I'll do this quick and then Jeff can jump in. It's actually quite easy to run an algorithm or a spreadsheet over how many machines you've got, how many orders you've got, what's the number of hours this thing takes to make, and then add a bit of buffer time in. But no one seems to have the simple process where, Mark, I'm on the phone to you, I'm the salesperson, and I'm saying, we can have this to you in 6 or 8 weeks. There just needs to be a screen where I can go, check, do we have capacity or not? It's baffling to me that this doesn't exist. And it's because people are accepting orders, they don't actually know whether they have the capacity or not. It's crazy. The second problem is a weird incentives thing where, margins are getting squeezed and no one's being honest at the fact that, like, hey, Mark, you're $1,000 a week spend for us. Boeing's $100,000 a week on the commercial side. Like, if they whip us and say, you need to do this in 4 weeks, we're going to move you out of the way. I don't actually think that's a bad thing, but there needs to be upfront with like surge pricing where everyone is paying for guaranteed lead times. And we're doing this load balancing like Uber or AWS does their pricing. And they're two very simple solutions. And again, it's just puzzle pieces. And for some reason, no one's doing it. And that's why the lead times are wacky, is because no one's doing the capacity maths. And Jeff, I don't know if that was what you were thinking, but.
All right, so I think that those views are ones that I wholeheartedly concur with. I think also to layer on some additional dimensions that we see, I really think that the ability to sort of marshal historical experience in a way that helps you have a clear-eyed picture of what capacity is going to look like is a big problem, certainly in electronics manufacturing. I think that just given the complexity of these pitted wireboard assemblies, there's so many things can go wrong, and like millions of components, sort of tons of different board types, et cetera, and I think that it's hard for some person, even with a decades-long career, to go and sort of say like, hey, here's all the things that could possibly go wrong with this design. Whereas I think that when you have a software that's able to marshal every single design that's ever come through our doors and say like, hey, when we've seen things that look like this, they tend to result in problems like this. Your ability to sort of think clearly about how long something will actually take really upgrades materially. So that's part of it that we think have seen as a problem and are really passionate about addressing.
We have a follow-up question to the question that pertained to the vertical integration. And the question is, has COVID-19 changed your perspective on this in any way? So this was the trend in commercial companies to go to vertical integration. And what is the impact, in your opinion, of COVID-19?
I don't think it's changed my opinion. I think it's shown a lot of people in the Defense Department community how fragile the supply chain is. People knew it was a problem, but I think the realization that, oh no, these are all small businesses, and the average small business in America has about 20 days worth of cash on hand. And it's a house of cards, and we better start pumping cash into the supply chain. So I don't think it's changed my opinion. I think, you see things like Zoom, where everyone was going to adopt Zoom eventually, or online shopping, but COVID has done 10 years worth of adoption in 10 weeks. And I'm hoping that people, this is now not a problem that's being talked about in 5 years, it's talked about now. And that one good side benefit of this terrible crisis is that people realize how bad this is going to get really quickly. And we do it now, and it doesn't get, shoved off to the next defense budget in 2024 or something like that.
I think if I can add, I think that another dimension of the, like, I think it changes the part of the internal cost equation, and that, like, I think about it as being fairly irresponsible to, if you're going to go and bring something in source, to do it single site, which I think would be a natural place to start. But I mean, I think folks have seen, like, COVID can really wipe out a location for their production for a while, and if you don't have that redundancy, the whole program is going to grind to a halt if you do that. And so I think one of the merits of either having multiple sites or multiple suppliers that you can use as a escape hatch is that you can, it's kind of a get out of jail card in case that COVID really wipes out one of your locations.
Excellent. All right, so I'd like to take a couple minutes here to give each of you an opportunity for your closing remarks and any key takeaways. We can start with Chris.
Yeah, I just say, firstly, thank you to Mark for sharing your own personal experience. You know, my big bugbear with this industry is no one knows how bad it is, and it takes someone who's actually experienced it from the customer side to make people realize that, firstly, it's solvable, but it's actually a huge, huge problem. And the second one is, I would say, you know, there is communities in, you know, both out of Stanford in the search fund community looking at acquisitions, in supply chain, in, you know, blue collar businesses that traditionally none of that investment capital was there, really entrepreneurial people who are doing it for the right reasons, and in Silicon Valley. So I would say, you know, watch out over the next couple of years, because people aren't building dog walking apps anymore, or acquiring recurring revenue services businesses. We're going after these critical industries, and I mean that in a good way. So, you know, the cavalry is coming is the message that I would send.
Well done. Jeff?
Yeah, so I think I thought that the problems were outlined with a good degree of articulateness, and I think that it's an exciting time. I think that there's big problems, and I think that we have a great opportunity to solve them. I think that, I guess, in our view, having more of a digital and software-driven manufacturing process is going to unlock sort of a speed, a quality, and on-time delivery that's going to be crucial for aerospace and defense customers to accomplish their missions, whatever they happen to be.
Thank you. Suman?
Yeah, thanks. I agree with the comments made by the other two panelists. The last couple of points I would like to make is, I think the COVID-19 crisis has been a major wake-up call to entire classes of industries, and I think there are going to be there's going to be tremendous supply chain reconfiguration, and the reduction of overdependence on remote supply chains. This is going to lead to some pretty interesting developments in manufacturing, just like was mentioned a couple of minutes ago by Jeff about software-enabled manufacturing. I think that paradigm is going to proliferate quite a bit. There's going to be a greater integration from design through simulation to production to logistics. That is going to get vertically integrated. We're going to take advantages of the advances made in all the cloud innovations that have taken place. Along with that, the advances in additive manufacturing, 3D printing, moving more towards production. There are going to be new entities that are going to come up. There are going to be acquisitions in this space. I think the government, depending upon, of course, who gets elected in November, is also going to make investments in order to reduce America's overdependence on remote supply chains. And I think overall this is going to be good. It's going to be a really good time. I think that in 2 years' time, when hopefully the economy comes out of this kind of tailspin, that there will be the emergence of entire new classes of companies and industries that are going to support manufacturing in the United States.
Thank you very much.